And everybody should see my screen, and we are recording. First thing I want to talk about is announcements. And the announcements I'm going to talk about is last week of class. There's your first announcement. Hold on, let me fix the blinds. My cats have been playing with the blinds. Okay. Last day of class is Tuesday, November 24th. That makes Monday, the 23rd, the last day for y'all. We will finish 11.1 and 11.2 today. That will give y'all Friday, and today and Wednesday we will finish 11.1 and 11.2. That will give you Friday and Monday for questions on chapter 7 and 8. The last day of class, on that day, the homework will terminate, except for I'll probably let the chapter 7 and 8, I'll probably leave it open until the last day of finals, which will be the 7th. So that might be, I might leave y'all's open. Last test, final exam and last test. The last test will be on probability and statistics. We'll start on the 23rd and end on December 7th. Homework will terminate, all homework will probably terminate on the 23rd, except for chapter 7 and 8. And I'll probably leave it open, 7 and 8, I'll probably leave it open until the 7th. Last test will cover whatever material I cover, which I will finish probability and statistics today or Wednesday. Final exam, 2 attempts, takes the higher of the two. 25 to 33 questions, and they will be all math questions, no bonus questions. And how do you get ready for this test? Well, you review your old test, which you can go through the grade book and review, and you can look at your old test. 2 hours to take the test. I only make it 1 hour long, so you should be able to finish it in double time. And it will be, the final exam will start on the 23rd and end on the 7th. Now, I have been known to do funny things with My Labs Plus the last week of class, and it usually benefits the student. So if you see something funny on My Labs Plus, go with it. Please do not send me an email that tells me you're confused. Just go with it. Okay? Any questions on any of the information I just gave you? Okay. Well, let's get on with probability. It ain't going to be a very lot. It's only 2 sections. What is probability? Well, the first thing I'm going to tell you is probability is the assigning a prediction to an event based on logic, experience, and stats. Okay, I'm going to give you an example of what I'm talking about. Wild Hog Road connects Highway 24 to Pendleton, basically. Waffle House is right there in Pendleton. Pendleton High School is right here. Wild Hog Road is right there. Wild Hog Road, it takes about 16 to 20 minutes to travel. And it connects West Anderson with Pendleton. If you didn't have Wild Hog Road, you'd have to go 85 or you'd have to go Clemson Boulevard. Okay? Now, there's some other ways, of course, I know that. But I'm talking as far as West Anderson. You get on Wild Hog Road, let's say you got an 8 o'clock class, it takes 16 minutes to travel. You get on Wild Hog Road right here at 24 at 7:30. You're going to be late for class. Why? Because when you get on Wild Hog Road, there's always going to be the blue-haired ladies club, the little old blue-haired ladies club, and they're going to be right there. They'll get on. They got CBs and radios, and they communicate up and down Wild Hog Road. Can anybody tell me what the little blue-haired ladies club do? What do they do with their vehicles? Little blue-haired ladies club. What do they do when they get in their vehicle? Oh, come on, people. Y'all not going to talk to me?
They don't drive fast.
Okay, how fast did they get up to, Miss Cersei?
Probably about 35.
They get to 33 miles an hour, and they do not know how to go faster than 33 miles per hour. And you're going to get behind that blue letter. It's just as soon as you turn on the Wild Hog Road, they're going to come out right there at that first road. They're going to come out and they're going to get in front of you. And they're going to stay in front of you. And they're going to get up to about right up here. And you know what you're going to say to yourself? I bet they're going to turn left. And just as soon as you say that, what do? They turn on their left turn signal. And they're going to turn left. Now, did you just predict the future?
Pretty much.
No, you didn't. What you did is you assigned a prediction based on logic and experience. I traveled that road for 15 years when I worked at the Anderson campus. Traveled it for 15 years. Experience. Well, what about logic? Well, if you live in West Anderson and you're traveling Wild Hog Road, there's two destinations that you have. One is the Pendleton, Clemson area. Pendleton, Clemson. The other is Sandy Springs. Now, how did I know that little old lady wasn't going to Sandy Springs? If you're familiar with Wild Hog Road. Anybody? Okay, y'all just not going to talk to me this morning or what? Because I know y'all know Wild Hog Road. Some of y'all are from Anderson. Y'all know Wild Hog Road. I don't know that road. You don't? Wow.
I live in Easley.
Oh, okay, that's right. You live in Easley. There's 3 or 4 turnoffs to get to Sandy Springs. So how did I know she wasn't going to Sandy Springs? She would have turned off one of these 3 turnoffs. So logic and experience told me that she was going to turn left. That is what probability is. Has anybody ever told you that they could tell the future? Anybody ever told you that they could tell the future? All you got to do is ask them one question. Somebody tell me what question that is if somebody tells you they can tell the future. What's the one question you would ask them? Miss Cersei, have I pissed off this class or something or what?
I don't know, but I don't know the answer.
Mr. Brickman, you let me down. What's wrong, man?
My internet's being a little off right now. I don't know why. Sometimes it's working and then sometimes I can't hear.
I hear you fine.
But
I would ask for the lottery numbers. Oh, well, that's not what I do. You see, what I do is shut up, you're a fraud. Okay? If somebody walks up to you and tells you that they can tell the future, you ask them this question right here.
I'm just walking away.
Okay? And if they tell you, oh, well, that's not what I do, then call them a fraud because that's what they are. How many of you have played this, and how many of you have played 20 questions? How many of you have played that before, some form of game about like 20 questions? That uses what? It uses deduction. How many times you ever went into a fortune teller's office or their room and they start off by asking you questions? They already know you're depressed. How do they know you're depressed? Well, you're walking into a fortune teller's office. You're not going to be happy on cloud 9 and going into a fortune teller. You're already depressed about something. So they're going to go on that, and they're going to go with the 20 questions. And they're going to get it with the logic. And logically, they're going to tell you what you want to hear. Okay? So if anybody ever walks up to you and tells you that they can tell tell the future, just ask them one question. What are the lottery numbers for Friday night's lottery? Well, that's not what I do. Shut up, you're a fraud. What is probability? Probability of an event happening is the number of times something actually happens over the number of times something is tried. There's two types of probability. Hold on just a second. I got to fuss at a cat right quick. Sorry. One of my cats decided he wanted to get up on the table today, on the desk here. All right. The number of times something, now there's two types of probability. There is the theoretical which I call the Mayberry probability. And sometimes people put an H in that theoretical, and I can't remember if it's got an H in it or not. I think it does, but somebody look it up for me. And then there's what we call the physical probability. Which I think they call the classic, but I'm just going to call the physical probability. How many of you know your way around a deck of cards? Somebody volunteer. Somebody raise their hand. Who knows their deck of cards pretty good?
What you want to know?
Okay, what is the probability of picking a king in a deck of cards?
I don't know.
Anybody want to take a stab at it? Well, Miss Cersei just let us all down. So, how many of you have a idea?
Do you have 4 chances?
4 out of what?
52.
52. Okay, Miss Hatton, do you have a deck of cards in front of you?
No.
Miss Cersei, do you?
I can grab a deck, I think.
No, I'm just asking, do you?
No.
Well, how'd you know that?
It's be 2 cards in the deck.
So it's based on knowledge. It's based on prior knowledge, right?
Yes.
Yep.
If it's based on prior knowledge, that's called theoretical. You don't have a deck of cards in front of you. Neither of you had a deck of cards in front of you, but you could tell me that it was 4 over 52 and you don't have a deck of cards in front of you. That's because it's based on prior knowledge. You know that there's 4 kings in a deck of cards, and you know that there's 52 in a deck. So you just gave me a theoretical probability. Theoretical is based on the math that you know, the numbers that you know from prior knowledge. Physical probability is if Miss Hatton took a deck of cards, shuffled them up, and drew one time, wrote it down, shuffled it up, drew another card, wrote it down, shuffled it up, drawed another card, and so on. That's physical probability. Okay? Sorry. I don't know why my cat is all of a sudden wanting to be an assistant today. Okay? So the physical probability is when you're actually doing it. So if you roll a die 3 times or 10 times, let's say you roll a die 3 times, or let's say 5 times, and you roll the die and you get 1, 3, 4, 3, 2. Okay? Then what is the probability of a 3? Probability of 3 would be 2 out of 5. Because you got 2 out of 5 rolls. Okay? Now, the probability of a die, of a probability of a 3 in theoretical world is 1/6. Let me divide this. I don't want y'all thinking, okay? Okay, this is a probability of rolling a 3 on a die. Probability of rolling a 3 on a die is 1/6, but you actually rolled it 5 times, and you got 2/5, which is equal to 5 will go into 10. 2 times, let's see, 2 times 4/10. 0.4. Why don't these match? 1/6 is 0.17. Why don't these two match? Because the physical probability usually does not equal the theoretical probability. Why? Because theoretical, did anybody look, is it RH or is it RE? I appreciate y'all looking it up for me. Thank you very much. I'll do it myself. Don't look now. Theoretical. Theoretical. It is without, I thought there was an H in there. Okay. It is without an H. Thank you. I appreciate y'all helping me out there.
You're welcome.
Y'all suck. Theoretical does not equal the physical. Unless you use what we call the law of large numbers. The law of large numbers kind of is like CYA, and we all know what CYA means. Cover your backside. When you do the law of large numbers, it makes the theoretical equal or get close to, the physical get close to the theoretical. Why would you want that? Because the closer these two are together, the better your research is, the better your prediction is. You want this. This is what you want. In MIT, there was 2 students, and they took a roll of quarters, and they measured the roll of quarters. They measured each quarter. They measured it, did an infrared scan on it, measured the density of each one, measured the diameter, and they put all that data into one quarter. And they made a algorithmic quarter to use in a program. And they wrote a program to flip that quarter so many times, that way you wouldn't have to flip it physically, okay? What is the probability of a quarter being on tails? What is the probability of tails? Anybody know?
Nope.
Okay, well, how many sides of a quarter are there?
2.
And how many are tails? What?
1.
1. So the probability is 0.5. They took that quarter and they wrote a program. Does anybody know how many flips it took to get a probability of 0.49999999? Does anybody know how many flips it took to get that computer-generated quarter to get on tails at 0.5? Anybody know how many flips?
I don't. Just 1.
100,000 flips.
Oh, I was really off.
Huh.
There's a lot of flips.
Yeah, that's the large number rule. If your goal is to do a good research project, are you going to research 5 people or are you going to research 500?
500.
500. Now, the lazy people don't want to hear that. Okay? That's why too many lazy people aren't in research, because you have to go out and actually do the work. If you want to turn in a half-assed project, you do 5 people. If you want to turn in a good project that's a good predictor and it has good stats behind it, you're going to survey 500 people. Okay? That's the law of large numbers. 3 test questions. Theoretical is based on the knowledge you have of a die or a coin or a deck of cards. Physical probability is actually doing it. And both of them are the number of times something happens over the number of times something tried. Just like there's 4 kings out of 52 cards. There's 1 number 3 on a 6-sided die. There's 1 tails on a 2-sided coin. Okay? Third question, law of large numbers. What is your goal in probability and statistics? Your goal is to make a good project by getting the theoretical as close as possible. The physical as close as possible to the theoretical. And that means use a lot of research. Now, let's look at some of the slides and see what they say. Where is my 11.1? All right, write these things down. An experiment is controlled operation that yields a set of results. If I put a rat in a maze and put cheese at the opening or the exit, that's an experiment, and I'm going to watch and I'm going to see what happens. The possible results from experiments are called its outcomes. If the rat just sits there and does nothing, that's an outcome. If the mouse goes toward the cheese, that's an outcome. An event is a subcollection of outcomes. So events would be what happened at 9 o'clock, what happened at 10 o'clock, what happened at 11 o'clock. In other words, when I ran a different experiment, what happened? That's an event. The actual experiment could be considered an event. So those are 3 words you might see on a test or a standardized test. Question. Right, complaint. Empirical. Empirical probability is the relative frequency of occurrences of an event and determination by actual observations. Empirical is physical probability. Empirical. That goes right here where I said physical. Empirical. Theoretical is determined through study, prior knowledge, study. So empirical probability, actual what? Occurrence. Theoretical, study of prior knowledge. You don't have to write down everything else. Number of times something has occurred over the number of times something has been tried. Okay, in 100 tosses of a fair coin, 44 landed heads. So what is the empirical probability? Well, I'm going to go to my handy dandy. So you flipped a coin 100 times. And you got 44 with heads. Therefore, the probability of heads is equal to 44 over 100 or 0.44. Therefore, the probability of tails for this coin is what we call the complement. This is the complement. Complement is the other side. So if we've got heads, 0.44, tails is going to be 0.56. Remember, the complement is always what makes up the whole with heads. Well, what makes up the whole with heads? Tails. What makes up the whole with no? Yes. What makes up the whole with true? False. What makes up the whole with black? White. What makes up the whole with innocent? Guilty. And so on. Now, what is the theoretical probability of heads? The theoretical probability of heads is equal to 0.5. That's the theoretical probability. And we see it does not match. And they usually don't unless you do a large number of flips. Anybody got a question? Oh yeah, that's right. Y'all not talking to me today. It's okay. I'm not going to get into this, but I will let you get into dominant and recessive. So you might want to write that down. Dominant means, in genetics, dominant means overcome. Brown eyes are dominant. Okay. Just so happens that they're also the best people too, with people with brown eyes. Okay.
Thank you.
You're welcome. He labeled the green color and the wrinkle traits as recessive. In other words, it's recessed. In other words, laid back. Now I don't get into the, I don't ask questions on the genetics, okay? I feel like that's another subject that you can take that up in. I just use basic, on my test, I just use basic probability. I don't do the genetics, okay? So we're going to move on. There's the law of large numbers. I already told you that. You don't have to copy that down. Law of large numbers, basically, the more you do, the better off you are. There it is. There's my experiment. I mean, not the experiment, but the MIT experiment. Except they don't tell you the story. 100,000 times. And they got to 0.49770. That's that actual, I didn't know they had it in the slides. You don't have to write that down because you already wrote down the law of large numbers, but that's a good experiment. I mean, that's a good graphic to show you that if you just flip it 10 times, you're not going to get 0.5. You're only going to get 0.5 if you get up toward 100, 125,000 flips. Okay, the scale. In probability, you're going to have a scale. And that scale is going to be from 0 to 1. Basically, in probability, you work by decimals. Now, sometimes you will use a fraction or two, especially with odds, but most of the time, dominantly, you're going to work with decimals. Okay? This is less than likely. I don't know if you put an E in likely or not. Let's see, do you? You do. Okay. This is very likely. And this is somewhat likely. So from here on out, anything you get as far as a probability, you need to write it in terms of a decimal. Unless you're doing odds, and I tell students, if you're doing odds, which we're going to do after probability, then you want to leave it as a fraction. All right, these are 4 or 5 test questions. Let's do them. This is called theoretical probability. What is the probability of rolling a 2 on a die? What's the probability of rolling a 2 on a die? How many die are there?
It's 1 out of 6.
1 out of 6. Change that to 0.17 or 166 repeating. What is the probability of an even number? Well, if you got 6 sides, how many of them are even? You always divide the number by 2, 3. So 3 sides, that's 2, 4, and 6. 3 out of 6, which is 0.5. A number greater than 3. Probability of a number greater than 3. Tell me the numbers on a die that are greater than 3.
Four, 5, and 6.
So that'd be 3 numbers out of 6, which is 0.5 also. D and E are trick questions that are on my test and standardized test. Somebody tell me, without thinking too much, what is the probability of D? Oh my goodness, everybody should be shouting that out at the top of their lungs.
0.
0. And what is the probability of E? Remember, 0 is very unlikely and 1 is very likely. One. Those are 5 good test questions right there, theoretical. And I don't have a die in front of me. What numbers are less than 7? 1, 2, 3, 4, 5, 6. That's how many sides are on a die. So what's the probability of rolling a number less than 7? 100% or 1. Appreciate y'all interacting with me. Makes the class go by a whole lot faster. And they go through all of those. I'm not going to go through all of them. I just went through all of them. That's the complement. We talked about the complement. Now, this is something y'all need to know. How many suits are in a deck of cards? 4. How many cards? 13. And they're numbered. Ace can be 1 or 11. These cards are 10. Okay, y'all should know that. If you don't know that, you need to brush up on your cards. Okay, let's do these 4 or 5 questions. Out of a deck of cards, what is the probability? What is the probability of getting an 8? If you drew a card, what would be the probability of drawing an 8? Same as king. What would it be?
Four.
What?
You said 8.
What's
Is
the
it
probability of picking an 8?
4 over 52.
4 over 52. You can turn that into a decimal. I'm not going to turn it into a decimal because I need to move on. So if picking an 8 is 4 out of 52, what would be not picking an 8? Come on, don't make it hard.
48,
48 out of what?
52.
Okay, now we're gonna take the red highlighter out here because this is important. There's two things you need to recognize here. With these two questions, just A and B, this is considered winning or success, and this is considered losing / failure. Okay, if I was to ask you, what is the probability of picking an 8? That would be considered success because the question is in context of picking an 8. So that would be a win or success if you picked an 8. Also, this is the complement of this, or they're complements of each other. In other words, what makes up the whole from 4 out of 52? 48 out of 52. What makes up the whole of 48 to 52? 4 out of 52. So these are complements of each other. Okay. All right, let's do the next one. Somebody tell me the probability of a club. How many clubs are there? Just like the other suits, how many are there? How many?
14.
There's
14.
13.
Oh, 13.
There's 13 cards in each suit. The 13 over 52 is a club. A jack or a queen, a picture card. How many picture cards are there in a deck of cards? It says it right there. Just count them. How many?
8.
Well, no. How many? Okay, okay. How many in this sentence in D? How many of those are face cards? All of them. And how many are there? 3. And how many suits are there? There's 4 suits. So what's 4 times 3?
12.
12. This is a trick question. E. Picking a heart and a spade. Why is that a trick question? Because you can only pick one. Can't do that. You're only picking one card. The direction says what? Select what? One card. If you pick a heart and a spade, that's what? Picking 2 cards. So that's 0%. And F. What is the probability of picking a card greater than 5 and less than 9? Picking a card greater than 5 and less than 9. How many cards are there greater than 5 and less than 9? Somebody name them to me. What cards are greater than 5 and less than 9?
6, 7, and 8.
Thank you. And how many suits are there?
4.
So 3 times 4 is 12 out of 52. So how do you do these problems? Two things. You have to read, and you have to what? Think. You have to read, and you have to think. Some of y'all are going, oh God, we got to think. And they go through all of those. I'm not going to go through all of those. Let's see, we already went through that. Now the next section should be on, and I know I'm running out of time, odds. That's what it should be. And I'm going to go ahead and tell you what the probability of odds are. This is where you want to keep things in terms of fractions. There's odds against and odds in favor. And they're just reciprocals of each other. Odds against is the probability of failure over the probability of success. The probability, and I mean the odds in favor, is the probability of success over the probability of failure. I would highly suggest that you make sure you keep your work in fractions, because it makes the math a whole lot easier. Okay? Now, I want you to write that down, and that's going to be your final notes today, because we're going to go into that Wednesday. Okay, let me finish with cutting this off.